Hello everyone, it's September 23rd. Alright, it's kind of getting late. I work a little bit too long on the other thing, on my app. So wasted about an hour there because I tried to upgrade to React Native 0.70. I was like, whoa, new version came out. And I do need to upgrade because the current version I'm using has some issues. Has some issues that React Native testing library cannot resolve. Basically, it's just with a modal. When you modal, you set it's visible to false. The testing library still renders it in the in a query. Still, you can get it, and that's kind of creating a lot of obstacles. And I don't want it to be that way. Which means we have, according to that library, it does say that if you upgrade to 0.67, the issue shall be resolved. So I just, I thought maybe I can just upgrade to 0.7, which definitely shall resolve things. Took me an hour to upgrade because React Native upgrade is always slow. Lots of trouble, like lots and lots of trouble, and it didn't work. It didn't work, and then I remembered each time we do the upgrade, it's a hassle. It's a huge hassle. So in the past, what worked was just create a new project, a brand new project. And in this new project, we use whatever React Native version we want to use. And then we just copy the files from the old project to the new project and make sure everything works, right? And then we claim that we have successfully migrated. That's the only way. There's no other way that I can see to make this work. And every time it's going to be a hassle. And I'm just not in the mood. We are not in the stage where we can afford the luxury of doing this. So we have to do some of the testing in a very suboptimal way. Because ideally, you should just test whether a component shows up or not. But for modal, we cannot test like that. So all we can do is to test the props, which you shouldn't, right? You really shouldn't test the prop, but we have to test the prop just to see if the prop is true or false, and that's the only thing we can do. Other than that, we just can't. But anyway, let's do today. We got lucky. I was actually preparing for a hard one, but it's a medium, so I think we can mow through this really fast, and I want to check the solution for this one. That's the real thing I want to deal with. But before doing that, all right, there's a bug, not a bug in the program. There's an insect. I kind of worried that the insect is a roach, but it's not. So let's take a look. Path sum number 2. Given a root and integer target sum, return all root to leaf paths where the sum of the node values in the path equals target sum. Each path should be returned as a list of the node values, not node references. A root to leaf path is a path starting from the root and end at any leaf node. A leaf node is a node with no two children. Doesn't seem to be that hard. I think we can just do it. Man, how time flies. September's about to end. Dude, it's such, and I feel like I haven't even done anything. Like I just started to get back to my study, to my research, but it's kind of, cannot fully put on that. But anyway, so let's deal with this. Let's don't think about that. Let's just do this. Okay, so we have a node, which has to be tree node. Actually, there's no possibility it's going to be a empty. And then have a path. We don't return anything. All right. So we say if node.left, or if not node.left and not node.right. This is the leaf node. How deep is this? 5,000. We can use sum. I mean, you can also sum along the way, depending on what you want to do. Lazy. If sum path is equal to target sum res.append path and copy it. Alright, and then return. Why you return this? Alright. Otherwise, so if node.left, then dfs node.left path.append. Path.append node.val. I think this should be the first one. Damn, man. Alright, path. Else. Path if node.right dfs node.right path. So we're done. Path.pop. So we have to do what's that? What is the thing I'm thinking about? Backtracking. Okay, let's see. What looks right to me? Yeah, that's fine. We have to do empty. How about 0? Empty and 1. It's not a valid of a type of integer. What? Sorry. The hell? Oh. 1, 2, 0. This one. This 0. I don't know what happened. Yep. Now what? What if it's empty? It should always be false. Alright. Not node. Don't just return. In this case, it has to be optional then. There you go. Okay, so nothing too bad. It's very straightforward. Well, we might be able to do this within 10 minutes. Yeah, I'd rather do it fast today. I don't think 10 minutes will work. Maybe 15 minutes. So we have to go through the solution for this one. 1 and 3. Straightforward, right? DFS with backtracking. Alright, nothing more to see here. Let's go to solutions. All right, what's this one? There's one approach. So my solution is different. Interesting. So they're trying to generate all possibilities. I mean, we can permute. That's true, we can permute. And then for each one, we generate all possible computations. What are all the possible computations? So the first one, either combine with the second one first, or the first one don't so for the first one, I either combine with the second one, and with the result, like how would you say? I can say either this by itself, the remaining we do, so we do the same thing with the remaining, or the first two combine, and we do the remaining, or the first three we combine. What do you mean the first three we combine? Well, what I mean is, for each one, it's either it by itself. So the remainder, we get all the values that can be computed by the remainder. And then we do this plus, minus, we do everything, right? Or first two combining, and then with the remaining. It makes sense. I might not do the same way as this, but this does point to an idea that I want to try. So the idea is I'll permute this whole thing. Permutation, right? Let's just deal with the first one. For card arrangement in permutation cards. Yeah, let's permutation. Permutations? Come on, man. Maybe it's permutations. No, it's not in here. No, it's permutations. There's an S. No, it's not that much, right? Then we say, we have to define a DP. Same as before, right? So we do the same. State, for this one, we'll return a different thing. We return a list of integers. Okay. Then we just say if not state, there's no target. There's no target. If not state, turn 0, right? If it is state, then we go through everything, right? We just say the same as here. This. So we do 1, right? 1, and then the result remaining, we give it to it. Or we say we'll combine the first two, and the remaining we'll do whatever we want. And we don't have to do combine the first three, right? Because that would be the same as, yes, we only need to do the 2 as well. So it's almost the same thing, but we're going to make it a little bit easier, right? So this is this. So we just get the first one, right? Get the first one. Yeah. Isolate. Isolate the first one. Isolate the first one. And combining the first two. Let me think. Isolate the first one. Isolate the first one. So I computed this, right? So I computed this. Or we can say we get these two, right? Then we try to do that. Isolate the first one. And break. So now I is pointing to the first one, right? I is pointing to the first one. So v equals card. Card. We have to pass card. Damn, card is something that'll never change. Whoa. No, instead of cards. Alright. So v shall be cards, this 3 minus I. So this is a current v. And then rest equals this. And then we say for remaining in PP, causes doesn't change, and then state exclusive or 1 left shift I, right? So this should be a list of integers. Then res.append, all possibilities is v plus rem. No, I can say res.extend v plus remaining, v minus remaining, v times remaining, and v divided by remaining. That's all. So that's isolate the first one. Now I say isolate the first two. Alright? First one remaining. And then we always get the first one, get the remaining. I get the first two. But we don't isolate the first three. Right? We don't have to do the first three, because if we do the first three, think about it. Maybe we should do the reverse as well, because we isolate this, can do this plus. So we should also do remaining minus v and the remaining divided by v. Alright? So if we go to first two, and then we also do this, then it's justified. Cards. I'm having second thought in this thing. What if the state is just a tuple? Current cards. It's going to be a tuple. What if it's this? Right? It's a tuple. And then it only has values. Right? It only has values. Oh, but it's okay. It's okay. So we just remove it. Then we can say if len current cards is equal to 1, right? We simply return list current cards because we return a list. And if len current cards is equal to 2, then we return, so we can say v1, v2 equals current cards. And we can return v1 plus v2, v1 times v2, v1 minus v2, and then v1 divided by v2. And I would like to say we can do this one as well. Because if the 2 causes a 1, 2, the result shall be same as 2, 1. So that's that. Right? Otherwise, then we can get the first one, and the remaining 3, we do this again. Right? Or we get the first 2, and the remaining 2, we do this again. So otherwise, we say v1, v equals current cards 1. Okay, that's a thing I don't know. Three. What if I do A1, A0? And oh, damn, man. How about A1? It's a tuple. So V is this, right? Then we just say for remaining in current cards 1 to the end, and then we do exactly the same thing, right? We do the same thing. This is to pick V at a start, and Maybe we shouldn't. Maybe we should just respect. I'm thinking. No, I think this is good. So we pick same. Of course, we have the rest equals this. So we pick the first, or as you can say v1. Technically speaking, it's v0, right? But it's fine. So if it's 3, yes. And say v2 equals current cars 1, then we can do whatever we want. I'm thinking. I think there are repeated computation in this method. Just trying to see if we can avoid the repeated computation. Wasn't that all the possibilities? No, it's not all the possibilities. Is it B at the front or D at the front? What we don't have is, we don't have DB. We don't have DB. So maybe let's just make it easier to follow the order. How about that? We just follow the order. We don't do the reverse. And we hit everything. What do you say? I say, okay, right? So what I say is, we just follow this order. Now this is 1, right? We get the remaining, and now we have 2. In fact, I make this into a set, right? And now I'm going to say this one, the union, a set. And then we do v2, right? And then v1, v2. Then we say for r1 in dp, v1, v2, for r2 in dp, current this 2 to the end. And this is going to be a set. Tuple and set. Alright, 2 to the end. Rest union set r1 plus r2, r1 minus r2, r1 times r2, and r1 divided by r2. And the 3. Yeah, we have to do 3 as well. So we pick 1, so 1, 3, 2, 2, and 3, 1. So we can do 3, and that's the same. Right, we do 3. Okay, so this is if it's 1, if it's 2, we can say if not current cards, return 0. One card, 2 card, and 3 card. So if it's a 0 card, 1 card, 2 card, so either 3 cards or 4 cards. So whether it's 3 cards or 4 cards, we'll always take 1, get the remaining. We can take 2, get the remaining. And then we say if len current cards is 4, then we can also say v3 is current cards 2, right? Then we say for r in dp current cards first 3. I might as well just don't do it that way. Don't need v1, v2. Okay, this is basically just first 2. So current cards, first 2, and then remaining 2. And this, basically we can say for R3 in DP current cards first 3. And then we do this. Yep. Let's call it R. This will be R plus current cards 3. Right, plus, minus, multiply, divide. So now we'll take 1 card, we'll take 2 cards, we'll take 3 cards. That's all. Then we're going to turn rest. So that's kind of a DP idea, right? So what do we do here?